Thanks for the intro, Dan. Tyler Crenshaw. I'm here to lead you guys through how to choose the right Q-SYS core processor, designing with Q-SYS core processors. If I can make my slides advance here, we'll go through the agenda real quick. So we'll talk kind of what is a Q-SYS core processor, right? We'll review a couple different topologies, centralized versus distributed, some network considerations. We'll introduce some of our new cores, the Core 24F and X class server cores. We'll talk a few times through this about choosing the right core, and then we'll look at a couple of examples in Q-SYS Designer. A quick review, QLAN. So QLAN is what drives the network between our core processors and peripherals, right? So it's kind of the network backbone between all of our network processors and the network peripherals. And it drives the full stack AV platform that Q-SYS is built on. All right, so Q-SYS, the full stack AV platform, that's our Q-SYS products, all of our native software, hardware, and services. That's our cores, our peripherals, endpoints, all that kind of fun stuff. Q-SYS Open, that's our industry standard protocols and tools. Things like CSS, Lua, AES67. Our Q-SYS partners, people like Microsoft, Lenovo. We recently announced collaboration with Sennheiser for some of their ceiling mics. And all of that runs on the Q-SYS AV platform, which consists of multimodal AV. So things like cameras, analog I/O endpoints, the NV series, the new NVM series video peripherals, the Intelligent Platform OS, that's Q-SYS OS, it's the operating system that all of our peripherals run on, and the Cognitive Cloud, that's going to be reflect all your monitoring and control up through the cloud there. So how do you choose the right core, right? The first thing to ask yourself is, what's the scale of your application? Are you a small meeting room? Are you maybe a little bit bigger? Are you a lecture hall? Or are you really big? Are you a full-on stadium or maybe an airport, right? So small, medium, large. Ask yourself that question. And then ask yourself, do I want to do this centralized? I've got one really big core running the whole thing. Or do I want to go distributed? I've got multiple cores, maybe one for each room. And they each have some pluses and minuses. Right in that centralized place, we've got, again, one core running the whole show. That means you can add new locations, maybe a little bit cheaper because you don't have to buy a new core. You just have to buy the endpoints. It's a little bit simpler for management and maintenance because you do just have that central hub. And it's easier to implement security-wise because again, you have that one central hub that everything passes through. It's also one point of failure, and it's maybe a little bit less flexible because to update a room, you've got to take the whole system down. To add a room, you've got to take the whole system down. So maybe you might want to do distributed instead. So there, again, you've got a core in every space. It's suitable for larger places or multiple locations where you need to spread your resources out. In this case, you don't have to take the whole system down for updates. You just take the room down you're working on. You do end up needing maybe a little bit more resources. You've got to buy a core for every space, but it enhances redundancy. You know, you've got, if one core goes down, it's not taking down your whole building. There's no single point of failure. And it can help some with network considerations, right? You don't have, maybe you're not passing that high bandwidth video traffic between every network switch. It kind of stays local to the room, right? There's also a hybrid approach, which we'll discuss a little bit more later. Zooming in on that centralized topology, we've got our one Q-SYS core processor. It's probably living in an IT rack somewhere, along with a Q-SYS NS series switch, or really any other standard network switch. In each room, we're going to have some endpoints, right? So we're going to have our audio, maybe analog I/O endpoints, maybe some video encoders or decoders. You're probably going to have a network switch in each room along with those endpoints. But in this scenario, we're running a meeting room, a lobby, an auditorium, and a reception desk, all off that one core processor, right? Flipping back over to distributed. Okay, so we've got, in this case, a Q-SYS core processor in every room, along with that network switch. In these rooms, you're still going to have those audio and control endpoints, although maybe your core processor has some of that built in. But in this scenario, again, you can take one room down, make changes without bringing the whole system down. It does add a little complexity if you're trying to do, maybe you need some background music to hit all of these spaces or paging to hit all of these spaces. It's certainly something we can do. It just is another layer on top. Another place that adds a little complexity is so you've got, you need to be able to monitor all of these cores, right? Back in the day when I started using Q-SYS, it was, oh, I had to go look at each core processor individually to see what kind of errors were going on. Or I cooked up something with SNMP so I could log it back to our IT database. But now we've got Reflect, so that makes it a little bit easier to see what all of your distributed systems are doing. You can just log into Reflect and see errors across all of your cores, or hopefully no errors on your cores. That's really what we want. Really with centralized or distributed, there's some networking considerations. So on the back of every core processor, there are two NICs. There's a LAN A and a LAN B. On the bigger server cores, there are actually four. There's a LAN A, a LAN B, an aux A, and an aux B. These are truly independent NICs. So each one can connect to a separate physical network for some advanced segmentation. There is no internal bridging between these NICs, so you're not going to get any kind of weird network loops if you tie one into one LAN and one into another. What we're showing here is some advanced segmentation, right? So we've got LAN A set up to be our primary AV LAN. You can see we have a gateway here. That way the core knows to get out to the rest of the world, essentially through that LAN A port with that gateway. We don't want you to have more than one gateway set on a core. That ends up confusing things for the core. It's going to be one of the first questions support asks you if you're having network issues. Do you have more than one gateway set? But maybe LAN B in this case is our control subnet, right? But we want that control subnet to also be able to talk to maybe the subnet our MTRs are on. What you can do in that case is add a static route here, which is what we've done. So anything on LAN B knows how to also get out to this, again, perhaps MTR subnet through that gateway. This LAN B would only be able to access this one subnet, 192.168.1, or this other subnet, 192.168.49. Everything else is going to flow through that LAN A, right? Some other network considerations, I mentioned LAN A, LAN B, aux A, and aux B. Real-time traffic can only happen on those first two, on LAN A or at LAN B. You've got QLAN, right? It's going to live on one of those two. It's going to live on LAN A, or if you want redundancy, LAN B. Dante can happen on either, but your real-time audio is locked down to LAN A or LAN B. Aux A and aux B are used primarily for control traffic. You can separate those across. It's good for isolating networks, maybe keeping high bandwidth traffic just on one LAN. Can isolate things for security reasons. One nice thing is, so you've got maybe your aux A for your control side. You don't want device discovery running on that network. It's really easy to come into Core Manager in your services and turn maybe device discovery off on whichever LAN you want. Save it, and then that's no longer going to be running there. Can improve performance, improve security, that sort of thing. Okay, so let's talk about the latest intros to our processor portfolio, the X-class server cores and the Core 24F. And those really illustrate two of the most common paths people take when they're selecting a core processor, whether they have onboard audio or not. So looking between small and medium spaces, maybe a meeting room, a classroom, or a lecture hall, ballroom, the biggest choice is, are you connecting any analog microphones or loudspeakers? If you are, great choice, the new Core 24F. It's a fully integrated audio, video, and control solution. It's a blank canvas to deliver unique experiences across a broad range of applications. It's the right capabilities for demanding applications. It's really the only processor in its class with ample onboard I/O and network I/O capacity It's got that onboard I/O for mics, other audio sources, GPIO, RS-232, and plenty of network I/O. I'm sure a lot of you guys remember the Core 110F, right? It's a classic, introduced in 2015. It was the industry's first truly integrated audio, video, and control processor, designed with collaboration, meeting spaces in mind, software-based AEC and integrated control. It was really a game-changing feature set. All right, it had the right features and convenience. It was a great fit for a lot of different applications. Been around for 10 years. It's time for it to retire, go off to the pasture, run around with the other dogs. The Core 24F, if it is its evolutionary successor. Significant increase in processing power. We've got 2 times the DSP, right? 25% increase in networked I/O capacity, increases in Dante audio capacity, AEC processors, media WAN channel capacity, and peripheral capacity. It's intended to fit in all of the same areas as the 110F was, same form factor, but more horsepower, right? We also brought back the OLED screen on the front, that got removed from the Core 110 due to some supply chain issues. Brought it back along with that GPIO on the back. One thing I'd like to note is we're suggesting this as the minimum core choice for running Vision Suite Designer when it's released. Most of the processing for Vision Suite Designer happens on a VSA 100, but there is some extra grunt needed on the core, so we're suggesting the Core 24F is the minimum there. I mentioned it's got that onboard I/O, right? It's got that GPIO. It's got integrated USB AV bridging, so you can tie a room PC in. You don't need that extra rack space for external I/O frames or any other networked I/O. And we've got software definable flex channels to let you tailor the system to your specific needs, right? Looking at a line diagram. So this is a lecture hall. It's a great choice for the Core 24F. We've got some wireless mics over here, right? Uh-oh, that is broken on my machine right now. And I lost my PowerPoint. Give me just a second. Uh-oh. We'll get there. Momentary lapse. So close. And we're there. Okay, back to where we were. So we've got these wireless mic transmitters tying in analog to the Core 24F. We've got some assisted listening tied in analog and a stereo audio player. We're bridging that room PC over USB to bring those Q-SYS cameras in. We've got some NV devices running over the network. We've got some Sennheiser Team Connect Ceiling 2 microphones tied in over Dante to the network. We've got that GPIO connected to occupancy sensors and shades. A good amount of Q-SYS peripherals in here. Some analog I/O, some networked I/O. Again, great fit for the Core 24F. And diving in specifically to that analog I/O, you can see we've got our mic line inputs there, all 8 mics tied in. We're utilizing those flex channels, and those are software definable. Those can be inputs or outputs. You don't have to decide that at design time. You can actually change that in runtime live to either an input or an output. And then we've got assisted listening tied into our outputs. You can see on the far right side, we have those GPIO inputs. We're tied into an occupancy sensor. And then we're using a 1K resistor in line with that GPIO output to control some shades. That 1K resistor kind of helps us get a little bit closer to 12 volts to actually control that shade, right? Okay, so we've talked about kind of the biggest thing you need to look at when you're doing a smaller medium room. Do you have any analog microphones? What if you have a larger space? More than likely, a lot of that is going to be networked I/O, right? You're going to have networked endpoints, bringing in all of your I/O. Really, when you've got that, you need to have a core that's got a lot of network processing, a lot of headroom. Maybe you've got some stereo channels. You've got a lot of AEC. It's just a demanding application, right? That's when the bigger server cores come into play, the X-class server cores. So what is the X-class? That's industry grade server hardware, right? It's industry tested, includes the most powerful processing technology and proven hardware reliability. Um, Fully networked I/O. Again, there's no I/O on the back of these guys. There are some USB ports, but the USB ports you can't use them in Q-SYS. They're just there because they're commercial off the shelf hardware, right? Um, they feature our flexible software foundation that enables ongoing feature and functionality updates at the software level. They're ideal for that mission critical service, right? Diving in specifically to the Core X10, it is 3 times the power of the Core 24F and a solid 12 times the power of a Core Nano. We've got 64 AEC channels here, 256 by 256 networked I/O, 128 by 128 Dante I/O. And I'll note there's no scaling licenses necessary on any of the server cores. They're fully capable out of the box. We remove those scaling licenses. So you're getting the full power of the core right off the bat. X20R, next up. The biggest thing to note on this guy is redundant hot swappable power supplies. All right. So this is kind of the successor to the Core 610. We added those hot swappable power supplies. We reduced the depth of the unit. We know people were having a hard time fitting these in standard AV racks. So we shrunk it down a little bit. No problems fitting in those racks. It's twice the power of the Core X10 and a full 24 times the power of the Core Nano. Those hot swappable power supplies, great for mission critical applications. And again, no scaling licenses required here. And if you need something even bigger, the Server Core X50R, 4096 by 4096 networked I/O. That is a lot of networked I/O. It's more than a 1 gig link can handle. So we're including two 10 gig fiber SFP plus, not NICs in those, but SFP plus ports, along with two 1 gig copper ports, right? If you're using, you can swap those SFP plus ports out for copper all the way around, but then you're limited to 512 by 512. Again, it's a bandwidth thing. 256 AEC channels, and 512 by 512 Dante network audio capacity. This is 5 times the DSP processing of the Core X10 and 8 times the networked I/O of the Core 5200. Right. So giant core, lots and lots of headroom. It's really the most mission critical applications. Typically, if you're running one of these, you're doing maybe like a whole theme park, a really, really big, massive stadium. You might even want to run 2 of these in redundant, right? So that way, if one of them goes down, it's not going to take down your whole theme park. And of course, no scaling license is required here either. So network only cores considerations. I mentioned that there is no I/O on the back of these guys. So all of your audio sources are going to come in through the QIO devices. We've got the smaller ones, maybe the 4-channel ones. We also recently released the high density QIO. So you've got 24F, and it's similar to the I/O on the back of a Core 24, right? Everything is flowing through that network. So you've got to have we'll have the headroom to scale into the future with these cores. All you need to do is connect your endpoints on the network and you're ready to go, right? Looking a little bit closer at the Server Core X10 in this divisible multi-purpose room. So you can see over on our left, we've got this Server Core X10 driving the whole thing, connected to a Q-SYS NS series switch, or again, just a standard network switch. We're bringing those wireless microphones in over analog into the CXQ amplifier. Remember, those CXQ amps have some analog I/O on the back of them. Great as a bridge into Q-SYS. We've got a bunch of different peripherals in here. You can see we've got the QIO ML4i bringing some microphones in. We've got some network cameras. We've got a Q-SYS NV21 in encoder mode. I don't know if you guys know the difference between encoder and encoder. An encoder is an encoder that has recently seen a mouse. Yeah, no laughs there. Okay, fair enough. Um, we've got the QIO GP 8x8 reading these partition sensors in, right? So that's another Q-SYS peripheral used here. We've got a bunch of Shure MXA 920s, routing Dante back over to that server X10, touchscreens. Just a great example of all of our endpoints being networked, feeding back into that server core X10, right? Server core X20, even bigger, getting the big boys. Okay, so this is a great example of a centralized processing topology. So we've got this server core X20, probably sitting in a networked AV closet, right? Um, it's driving all 8 of these meeting rooms. So each one has an SPAQ networked amp, some NV21 driving the video, and some NMT1 as the desktop microphones. And again, we've got 8 of those guys running on this. We've got a paging station, networked back in. We've got a lobby with a couple of things going on. And then we've got an auditorium where a little bit more serious AV is happening. Right, we've got the CXQ series network amps. We've got some more wireless mics running into a Flex 4A, also hitting a lighting controller. Some NV21 doing some video. One thing to note is we're not limited to just those centralized or distributed topologies. We could do something like a hybrid topology here, right? We could have this server core X20R running all of these meeting rooms, the reception desk, the lobby, some background music, that kind of thing. And then we could maybe throw a core 24F over in this auditorium to handle, maybe we've got a bunch more analog microphones. Maybe we've got, doesn't matter. But we could run this auditorium on its separate core. If we want to take it up and down for maintenance, we can do that no problem without affecting all of these other rooms. We can still run core-to-core paging in. We can still bring our background music in. We can integrate it in with these building-wide AV systems, right? So this is a good, really good example of either a centralized or a hybrid topology. Okay, so that's kind of a review of our new cores. Again, the Core 24F or the server cores. I want to bring up really kind of the first thing that I look at when I'm trying to help somebody pick a core. This is kind of a cheat sheet of all of our cores, right? Their total network I/O capacity, their Dante channels, their AEC. This is available at qsys.com/cores. This is a great place to kind of see the broad overview. But what if you need more of like a back-of-the-napkin decision tree? We've got you covered there as well. So again, that was what is the size space? You've got a small or medium space. Do you need that analog I/O? If no, a small space, a Core Nano might get you by. Or if you've got a medium space, maybe a server Core X10. Another good option, if you need something in between those, you can apply that scaling license to the Core Nano and get double the DSP on it. If you do need that analog I/O, great core for a small room is Core 8 Flex. Actually, I have one of those running at my desk right now. Why do I need a core running at my desk? Because I work at Q-SYS and they gave me one. That's why. If you've got maybe a little bit bigger room, again, the Core 24F, great choice. One thing not shown here is the NV32. The NV32 can run as a core. If you're running maybe some HDMI, the NV32 can be run as a core processor with a 3x2 local matrix, or you can pair it with the core streaming license and use it as an encoder or a decoder. It's great for meeting rooms, classrooms. It's got around the same processing power as the Core Nano or the Core 8 Flex. So small, but powerful. And zooming out all the way, what's the scale of our application? Small, medium, large. The next question is, are we connecting any analog microphones or loudspeakers? Right. So a great decision tree. Grab a screenshot there, save it, stick it, set it as your desktop. Right. That way you can look at it every time you open your computer. So Q-SYS control. If you're not using Q-SYS control, highly encourage you to start. We've got some low code, medium code, some no code, low code, and full code options for control, right? We can utilize that Q-SYS control engine without the need for a UCI deployment or scripting license now. We got rid of those with version 10, no longer required, right? And that allows you to deliver a unique user control and automation experience in any space. For previous versions that still want that scripting license or UCI license, we actually offer those EIDs for free on our website now. I believe you can search the knowledge base for that. We don't sell them anymore. We just offer them for free. So more feature license updates. So we took the scaling license for the Core Nano and Core 8 Flex and combined them, right? It's just one SKU for the scaling license, make it a little bit simpler. I mentioned that basically doubles the processing power, and it increases the network channel capacity on those guys. We took that multi-track playback feature license and made it stackable, so it's a little bit easier to order and deploy. And the capacity scaling license for the bigger cores has gone away. Now all of those bigger cores are fully ready to go out of the box. Okay, we're at the point now I want to look at a couple examples in Q-SYS Designer. But before I dive directly into Q-SYS Designer, I want to talk about these redundant hot swappable power supplies in the Core X20R and X50R. Ooh, I'm gonna sip of water first. So out of the box, these cores are set to essentially, if they're set to redundant power, which needs to be set in the core properties, you've got two power supplies, and they each draw 50% power into the core. Either power supply can supply 100%, but in its default configuration, if you plug them both in, they're both providing 50% power. Kind of just a little bit easier on the power supplies that way, all right? If one of them falls off, the other one's going to take over to 100%, but they share the power in the default configuration. If you need to change that, say you've got maybe two grids you want to tie into. I know I've worked in some stadiums that have redundant power grids going to them. You can go into Dell's iDRAC. You know, I mentioned that the bigger server cores have 4 NICs on the back. I lied. They actually have 5. One of them is dedicated to this iDRAC. It's Dell's like out-of-band management platform, essentially. So what that allows you to do is hop in and configure some settings on the server. I typically would not leave that tied in all the time. I would set this up and then unplug it unless your IT administrator tells you otherwise. But you can set these power supplies to, instead of being not redundant, set them to be AB grid redundant, and then you can enable hot swapping. And then you can also say, hey, I want power supply 1 or power supply 2 to be hot. That way you can have maybe a primary grid that power supply 1 is plugged into, and a secondary grid power supply that your power supply 2 is plugged into. All right, now let me pull up some examples here. Okay, so looking at this X20R on its status block, and click into it, you can see I have redundant power set to yes over here. I'd also like to note that I have verbose mode turned on in the core properties. So that's one thing I like to do on really every core I set up. It doesn't hurt anything, and it gives you a little bit of extra information. And the biggest things it gives you is you've got memory usage here. So it's going to show you how much memory your core is using. That can help you see when maybe a script has a memory leak. You see this number increasing over time. Something has a memory leak. You've got control compute usage. That's going to show you the CPU of kind of the background control processes happening on the core. Network compute usage. This is how much network, how much CPU is your network using on the core. The process compute, I believe, is some of the background Linux processes happening on the core. But the really big one I like to watch is this Lua compute usage. Right, this is going to show you the compute usage of all of your scripts and plugins combined. If you're hovering around 85% or higher, I like to say you maybe either need a bigger core, need to look at paring some of your scripts down, or you maybe just have a problem with one of your scripts. You can use this inspector over here to look at all of your scripts individually and see if maybe one is taking up more CPU. But this Lua compute usage is a really good thing to look at if your core is acting a little squirrely, right? Scrolling on down, this is not part of the verbose mode. This shows up when you have a core set in redundant mode, right? So you have two cores working kind of together. You have a primary core that is active most of the time, right? But maybe it something happens to it, it falls offline. Your backup is going to take over, right? So your backup is going to run until you force the primary to take back over. We don't want the primary to maybe get stuck in a boot loop, right? It's booting, it's taking back over as active, it's falling off the network again. It's booting, it's taking it. We don't want you to get stuck in that loop. So we force you to make this go back to the active core, maybe after you fix the issue, right? Again, not part of verbose mode, but really important to know, hey, is my core the clock master? If not, who is the grandmaster? It's also going to show you if your core is a grandmaster. That's on the P2P V2 side, P2P V1 side, aka Dante. The MAC address of the master clock is going to be shown here. Again, not verbose mode, but your various LAN, LAN A and LAN B shown here. DSP statistics, that is part of verbose mode, but I really rarely look at that. It's more, it helps support out some. The main thing I like verbose mode for is this Lua compute usage, right? I've written some scripts that are good, and I've written some scripts that are bad, and this can help you tell the difference between the two. But we're really here today to look at these power supply LEDs, right? So we've got power supply 1 and power supply 2. Those are going to go green when they're both working. That evaluates out to a true when they're both working, right? That's how LEDs work. And Q-SYS, they're essentially Booleans, true or false. Looking at this logic, right? So we've got our power supply 1 and power supply 2 statuses tied into logic not blocks flowing through an OR. So if these are both true, they're going to evaluate the false. Will evaluate the false, so they won't do anything, all right? But if one of these falls offline, that's going to evaluate the true here, hit this control delay, and hit this emailer, which is going to send the last entry from our event log, which is probably, hey, you've got a power supply that just died. It's going to email that out to however we can figure this email, right? You can also see this through Core Manager, of course, and through Reflect. And if you've got some webhooks set up in Reflect, we'll send out that way as well. So this is a Core X20R, right? So it's a big boy core. We've got a lot of peripherals on this bad boy, right? We've got a bunch of audio I/O, including some Core 110 set in I/O mode. You set a Core 110, a Core 8 Flex, or Core 24F in I/O mode to allow you to get that the I/O from the back of those guys into another core. They stop acting as a core at that point. They just act as a peripheral. Got a couple cameras, some control I/O, lots of NV series stuff, lots of touchscreens. There's a lot of peripherals in here. I wonder if maybe it's a big boy core, but do we have too much? It's an easy way to check. We can come over here to File, check Design, and what that's going to do is crunch the numbers in the background for us, look at everything going on, and bring up a bunch of different things, right? We can see here we've got peripherals in yellow. We've maxed out our peripherals on this core at 256 peripherals. We've also maxed out our audio recorder channels at 4. We've got 128 audio tracks in here. But with all of that, we're only using 17% of our total signal processing. So we've got plenty of DSP left to go. We've got plenty of room for more AEC. We've got plenty of room for more Q-SYS mics. Pretty good amount of bandwidth left here, right? One great thing that check design shows is our the various licenses that are required by design. So here it's telling us we've got the multi-track player license that's required because we've got 128 audio tracks. It's also telling us we need the Q-SYS AV bridging license. More than likely that's in here because we're trying to bridge from a touchscreen. I believe that's the only place that that license is still required, is if you're bridging from a touchscreen. You can bridge from a core for free, bridge from an NV device for free. kind of thing. So, and it shows you the total number of peripherals in here. We used to license Reflect a little bit differently. Now a Reflect Plus license is just required for the system. This is one system, right? So just one license is required. Uh, Hopping back to this PowerPoint real quick, I want to bring this guy up again and kind of talk about a couple places that you might need to bump up to the next size core. Some places that I see people mess up, and oh, you really should have picked the next size core up. The biggest one is AEC channels. I see people try to use maybe an NV32 with more than 8 AEC channels. That can kind of sneak up on you sometimes. So I see, you need to increase your core there, or maybe for the Core Nano or Core 8 Flex, add that scaling license to it. But I believe that number doubles. The other place that I see people needing to bump up to the next size core without realizing it is Dante channels or networked I/O channels. So obviously we include I say obviously, we include an 8x8 Dante license with each of our cores, with the exception of the NV32, right? We don't include it with the NV32 because it can be used as a peripheral, and we don't want to pay Audinate an 8x8 license fee for every single one of those if it's used as a peripheral. But the other cores all include an 8x8 license. What you can't do is tie in 8 devices at one channel apiece, right? An 8x8 license is 4 streams, and essentially each device you connect eats up a stream. So you could connect 4 devices at 2 channels apiece, 3 devices divided by 8, whatever, 1 device with 8 channels, but you can't do 8 devices, 1 channel each. You would actually need to step up to the 16 by 16 license there. Just keep in mind your streams, your flows. I think the naming changes depending on what you're talking about there, but your stream count, right? So that's all I've got for you guys. Guess we can open it up for Q&A. Can stop sharing real quick. Michael, we have any questions?
I don't see any yet. You've done it so thoroughly well.
Man,
Um,
that's how good I am.
I'm watching it. Um, yeah.
Okay. Well,
Let's
Michael,
see.
did I miss anything? Anything you want to add? Michael's been around a little bit longer than me.
Well, all kinds of things to add, but I don't want to go down any rabbit holes.
We've got some
Okay, we've
time.
got a question. Can you or will you support stacking like AVB cores?
Hmm.
I'm thinking that's sort of from a perspective of another manufacturer, like passing the audio between the devices. We use QLAN, which is a robust standard we've been using for 13, 14 years. Um, Not likely to support AVB, although we kind of supported a flavor of it for a while with one of our cards in the 510. AVB kind of seems to be the Wild West as far as standards, so you'd be
Yeah.
adhering to one or the other. Like 2 cores acting as one programmatically.
We can, what Michael mentioned with QLAN, we can do things like share, not really share AEC, but say you've got 2 cores, you don't have enough AEC on one, you can use QLAN to pass those streams and the reference over to another core. Um, they don't act as one, but you can do some sharing.
The important characteristic to distinguish between having your design all in one core and distributing it to the other cores is the clocked nature of the audio. And do you need to send camera streams? Because that's the one thing you kind of can't send back and forth between designs. You can send AV streams, you can send audio and whatnot, but keeping in mind that certain forms of sending audio back and forth between cores are clocked, meaning they adhere to the precision time protocol, they're precisely timed, and others are not. If you're not actively looking at the person who's talking or looking at or dealing with a line array or something else where precise timing is important, it may not be important that they be clocked. Who can we contact and stuff? A question from Tony. Who can we contact to discuss our designs and make sure we're picking the right core? Uh, as an integrator, you should have access to your local salesperson and the local application engineer, such as Tyler and myself for the Southeast. There's essentially there's a map online through your salespersons.
Yeah, but encourage you to reach out to your area manager first, unless you already have that relationship built with your application engineer. If you've already got that relationship, feel free to reach out. But we like to route it through the area manager first. Can you extend the USB BYOD from the core to a wall plate? So you could do USB routing with like an HID device, not necessarily to a wall plate, but like to an NVC. I mean, we've got a couple different devices with USB, right? Or AV bridging, but not necessarily to a wall plate. I've seen people do the AV bridging license on a touchscreen and then bring that down to a wall plate, but you need to be really, really specific about the cables used there. It's not a it's not a great solution, but it can work. Especially if you watch the USB cables that are used there. USB-C is fantastic, but as we all know, different cables support different things. So if an end user brings in a cable that doesn't support maybe, USB 3.2, you might not get the resolution that you want from that USB bridge.
Um, yeah, so as far as the Q-SYS peripherals, our wall plate peripheral is just the HDMI encoder, the NV1. Um, if you're asking if you can extend a USB BYOD or bridging connection, you could. I would just advise you to maybe see if you could get your hands on it and test it first. If
Yeah.
you're just going to extend something like that, because there's all sorts of standards at play. I believe the support department recommends using cabling and or extension system that's capable of supporting Thunderbolt 4, which is um, the latest standard to live. Mhm.
Cool. Yeah, USB-C is a little bit of the Wild West as far as
Yeah.
what cables are out there. Do they actually support the right standard? So, um, yeah, I encourage you to keep a stock of cables work for your users if you're an end user.
Mhm.
Who's excited for InfoComm next week? All right, Michael and I are going to be there, hanging out. Excited to enjoy some nice dry heat in the
Hmm.
desert.
Yeah, be sure to stop by the booth and or register to take a tour of it, or just sit in the standby line for a short time and take a tour of our booth. It's always very impressive with the interactivity of each of the exhibits and the rooms. We've got
And
a
check
lot
out
to
the
show.
audio demo room as well.
Yeah, yeah, right. Which is very close by.
Fun fact, the puppies at the show are right outside, not right outside, but they're like just right across from the audio demo room. So go play with a
Uh-huh.
puppy and then come listen to some Q-SYS speakers. We're here. We'll keep hanging out. We've still got a good number of participants hanging on. Drop your questions in. They don't necessarily have to be related to the right Q-SYS core processor. Uh, any burning Q-SYS questions you might
Yeah,
have.
really.
Don't ask what's that burning sensation because we don't know.
Yeah.
Uh,
It's not. Let's see. Uh, just gonna grab the contact us
oh yeah,
page of our
go ahead.
website and throw it in the chat um, regarding looking for your local sales professional. That would be the place to go. Click on the territory that you're in.
Well, if you guys are interested in trainings, um, That's something that we bring on the road. Let's see. Send out the slides with cores on it. Was that the overall, like each one had its spec sheet on it? That I believe is at qsys.com/cores. I'll see if I can find that and send it to him, Michael, if you want to look at the next one.
Yeah. Um, when will these changes be reflected in the current version of the exams? I'm assuming you mean like the addition of the X series cores. Um, Maybe not, but you know what? It's all the same game. It's all the same software inside of it. And our cores, aside from, the IO that's built or baked in, that's on the device, they all do the same things. They all do voice over IP and the QRC and media drives. They all have the same functionality. So it's the difference from one core to the next is capacity. What do you need at your install? But they all have the same functionality. We've run into situations where ACPR configurations, multiple blocks have pushed the limits of processing. Is there a way to verify CPU load? There is. When Tyler was showing the core status block, when it's in verbose mode, you can see, well, if it's, the ACPR plugin, it's going to be the Lua engine portion of that. Um, there's also, the design itself that you can check through check design. There's also something called the control compute usage, which is all of the processes going on in the core that are not directly related to audio, be it type 1 or type 2, the other processes, but not necessarily Lua plugins. All of the names and the tagging and the communication with the network, all that going back and forth. So yes, you can through verbose mode of the core status block and also through check design.
That doesn't necessarily show them in emulation mode before they have the core in hand. I would say if you are deploying an ACPR heavy room, I would probably step up a size maybe. I wouldn't try to run an ACPR heavy room on a Nano or an NV32. I'd
One
suggest
thing
maybe a
is,
10.
Tyler mentioned if you're doing anything with our presenter tracking, call it what you will, but our presenter tracking, you would need a 24F um, to do that effectively. What is the part number for the Euroblock that is used for redundancy connections?
I believe that's the Q-SYS. I'm looking that up right now.
Okay.
And that's for the high density QIO guys. It's some Euro blocks that go between the cores or between the peripherals. One
Yeah.
thing that's important to note is we actually can't do redundancy like that on the Core 24F. It's missing some of the relays needed to really do redundancy. I don't remember if it's on the inputs or the outputs that impedance becomes a problem. But we only advertise redundant analog IO redundancy on the high density QIO devices um, with that QIOCK.
Running
Yeah,
designs on a server core, can the design be updated or pushed into the core to update a room without causing the other rooms to go offline? Paraphrase. Um, if you have that centralized design, then no, the design will have to go down for a few seconds, less, or maybe a minute or so while the new design uploads. Using a distributed system where you have, cores in specialty rooms like the Nano in the classroom and a 24F in the auditorium, that could prevent that. Um, so no, we're not really partitioning uh, systems within a single core. Not at this point, we're not. Um, yeah.
that's one of those things that's been on the roadmap for a long, long time. Um, but I don't know where it is priority wise if it's ever going to happen. It is something that's been considered for sure, but it, you know, not anytime soon. I would say. Got me to someone specifically regarding Reflect. So if you've got like specific support questions, I'd say reach out to support. If you've got sales questions, technical questions, reach out to your area manager, and they can get out to us. I don't remember when that is shipping, and I'm not sure on the MSRP off the top of my head. Looks like Michael Perry is typing.
Yeah, Nilsson is actually in my area,
Okay.
so I'll reach out to him
Yeah.
outside of
Yeah.
this.
That's another one. I mean, reach out to your area manager, right? Your sales guy.
Yeah, and hopefully y'all can see that. It's just the contact us link that I put in the chat, not in the Q&A. Hopefully you see it and you can click on it, and that'll take you to a map where you can just click on the area that you need to. It'll be the salesperson and they can direct you to the application.
Hey, thank you, Michael Perry. All
All
right.
right. Let's see, did I miss any questions? ACPR.
I got an email the other day that said Michael Perry deserves a raise. And I said, I
Let's
agree.
SBIO in the wall.
I think we grabbed them all. I mean, we got a couple more minutes. Y'all can keep them coming.
Yeah, yeah, about anything Q-SYS related. Um, I think it's nice and it's important that we have an access manager, um, the ability to turn off certain network services
Yeah.
as Tyler was showing earlier on that slide. In situations where you don't need to have things like the external control protocol or the Q-SYS remote control or device discovery turned on certain network interface jacks, you can actually go in and turn that off. Your IT people are going to love that. Just show them that browser page and they'll love you.
We also have plenty of help guides that detail exactly like what ports, what kind of things are happening with those different
Mhm.
services, right? UDP, TCP, multicast, what
Yeah.
multicast addresses are being used some, for some of those discovery things. Lost the ability to talk for a second there.
Yeah.
Um,
And IT administrators in general don't like UDP multicast on their
yeah,
networks.
one of the reasons we offer our NS series switches, right? Those come out of the box configured, ready to go for Q-SYS. You really can just plug your Q-SYS devices in and have everything work. I tend to like to turn on DHCP on mine, but that's just me. Um, when you're tying into a corporate LAN, that's more when those network services and telling your IT administrator what's going on comes into play.
So here's a challenging question, not related to the course, but can the NC cameras send their video streams to the new NVM decoders for HDMI output? If so, what is the resolution available from that camera stream when it hits the HDMI?
So I know you can take, because the new NVM stuff is MediaCast based, right? The same thing as our camera. So you can take a camera, run it, sit it out that HDMI. I don't remember what our resolutions are off the top of my head for cameras. Um, but
Let's
yeah,
see.
you can send that stream out to the HDMI out. You can also send that MediaCast stream out of HDMI 1 of an NV32. Um, I know there are some changes coming to interop, um, but I mean, even the earlier version 10s, you could send that MediaCast out of an HDMI 1 of an NV32.
No, so Nelson was mentioning that you thought it was 1080i. I don't know of any instances where we're dealing with interlaced video. Um, I think it's all progressive. 1080p is what I would expect out of, let's say, an NV32.
Yeah,
It's HDMI 1 output that's receiving a media cast stream from one of our cameras. It would be 1080p unless it was downscaled for some reason to 720.
that sounds right.
Yeah. Um, Will the USB bridging camera output of the NV21 ever be upgraded from 720 to 1080?
It's one I don't know about any kind of roadmap on that one. I do know a lot of the times that Teams and Zoom end up squishing that down anyway, right? And compressing the hell out of it. So I'm not sure if that's ever going to get touched. I don't think it's, yeah, I'm not really sure, honestly. Um, One I would have to go ask our product managers on.
Interesting. All right.
Okay, I think we're hitting time now. I appreciate you guys stopping by. Really enjoyed it. This is my first webinar.
Mine too.
So I hope I didn't screw up too bad for you guys. Felt like it went pretty well. Michael, appreciate your help today
It was
answering
a
those
pleasure.
Q&As. And again, thank you guys for stopping by. So, all right, y'all have a good one.